Hi friends, welcome to our channel. In this video, we are going to look at problem 778, swim in rising water. Here, this problem can be solved using either Dijkstra's algorithm or breadth-first-based search plus binary search. So in this video, we are going to explain how to solve it using Dijkstra's algorithm, right? So first I want to mention that in our implementation of the Dijkstra's algorithm, there are two main ingredients. One is the mean heap and the other is relaxation. And the second thing we want to point out is that here the distance is 10 and the aggregation is not add but maximum, right? So with that said, let's come back to the problem statement. So here we are given a square grid which says n by m. So at time t, the water level is t, meaning that any cell with elevation less than or equal to t is submerged or reachable. So here one can swim from a square to another 4 directionally adjacent square if and only if the elevation of both squares, your source and target, individually are bounded above by t. So here you can swim infinite distances in 0 time. And we want to return the minimum time until you can reach the bottom right square. So here the top left is the source and the bottom right is the target. So if you look at the two examples, let's look at this one. It's because it says it's smaller and easier to analysis. So from at time t equals 0, you are at the top left. So you cannot move to the neighborhood to the right and downwards. The reason is that 1 and 2 are strictly larger than 0. And then you need to wait 1 unit time, and then you can reach to 1, 0 cell, that is the 1, right? And then at this stage, you cannot move to the destination. So you need to wait for 2 more unit time, and then you can reach to this one. So overall time will be 3, right? So here actually you can take this path. From 0, you wait for 2 units time, you can reach to the elevation 2 cells. And then you wait 1 more unit time, you reach the bottom right. So this is the same, right? So in our case, we are going to use Dijkstra's algorithm. The 0, 1, 3 path is the path we are going to choose because Dijkstra algorithm with the mean heap always choose the path with the minimum maximum elevation in the path, right? So with that said, let's look at the coding. So before that, let's quickly go over this one. This 3 gives the problem size, and this one actually is very good for binary search because it supplies the search range, and the elevations is unique, right? So now let's look at the implementation of Dijkstra's algorithm. So here, let's first get the size of the grid. So n, the size is a square one, and there's also the 4 directions we can move. The 0, 1, 0, negative 1, 1, 0, and negative 1, 0, right? So what we want to do is implement a Dijkstra's traversal function from a source or start to target. And then we are going to call this function f, the start is 0, 0, right? And the destination will be -1 and -1. So the main thing is to implement this function, so which is actually very routine. So first, let's get the priority queue. So it's going to be this grid at the start, right? So I will say grid 0, 0, and the start. So here, what we store is the time and the location. So the location is something like this. It's RC, right? The row and the column index. So here is 0, 0, right? So in other words, our start will be 0, 0. Or you write like this, start 0, start 1, right? This is the initialization for the priority queue. And then distances. So here for distances, you have two options. You can use a 2D array, or you can use a dictionary. So here, let's use dictionary. Collections, default, dict. So here, I'm going to map everything to be float infinity. In other words, if not visited yet or not considered yet, so we set its distance from the source to this is infinity. So then the distance is from the start. We'll set it to be great start 0 and start 1. Actually, for this problem, you can write this one as grade 0, 0, right? This is the one. And also, we are going to use specifically a set to monitor the cells visited to avoid repetition. And actually, you can use this distance also playing the role of this set, but let's do it in this way here. Then we are going to do the standard while loop if the priority queue is not empty. So we can first get the current distance and the current position. Let's write current node as heap queue, heap pop, right? Pop from this priority queue. So here actually we are using some modules in Python like this collections and heap queue. So typically you need to import like import collections, import import heap queue. But in leetcode you don't need to do this import explicitly. So with that said, let's first do a comparison. If current node equals the goal or the target, and then we just need to return the current distance. This is the one, right? And then if current node in visited, so we just continue, right? And next we are going to add the current position. So this current node to the set, and then check its neighbors. First, let's get the current node coordinates of row and column indices, right? And then what we are going to do is this for dx dy in moves. So this is the possible four directions. Then the point we are going to look at is this one. This is the cell we are going to look at. So we can write like this. Let's see, r equals x plus dx, and y equals rc, y plus dy. Then we want to check if this cell is inbound, if 0 less than or equal to r less than n, and 0 less than or equal to c less than n. If this is the case, so we can look at the distance. So we can find the max of the distance, so the current distance, and then the one from the grid, right? R and C, right? So if dist is less than distances, let's retrieve this RC, right? Then we are going to update distances RC to be the current distance, and then add this piece of information to the heap queue, heap push to this priority queue, and then what we are going to store is distance and the position, that is RC, right? So if we reached the destination, we should have some returns. Otherwise, we should return float infinity, meaning that we cannot reach the destination. So with that done, so actually what we need to do is just call this function and do this return, right? So before we make any comments, let's first do a test. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes the generic cases. So here, let me mention 2 points. So the first point is the 2 ingredients. One is mean heap. The mean heap is here. Right, this is the mean heap. And the relaxation is here, right? So other parts, basically, these are some initializations. This is the basic destination check, and this is the avoid repetition. So then, once you realize these 2 ingredients, more or less, you can implement the Dijkstra's algorithm, right? So this is one part. Another part is that here, the distance is time, not add, for example, here, right? It's max, not like in the in terms of general distance, right? So this is add. So with that said, that's basically about it for the current video's coding part. So here I want to make a comment. In the follow-up video, we are going to explain how to use binary search to solve this problem. So that actually follow another source routes. It's also very useful. Actually, a lot of the problem in LeetCode can be solving using binary search with some specified monotonicity function, right? Monotonicity yielding function, I would say. So you're welcome to follow up. So finally, if you find this video interesting, so you're welcome to thumbs up or share with your friend. Thank you for watching.